For this question, we're going to let f of x equal square root of x minus 2 and g of x equal x squared minus x. We want to find and simplify the expression. The expression we want to find and simplify is f plus g of 11. There are two different approaches that we can take for this example, and I'll show you both of them. On the first approach, we would start off by building the function that is described here. So we would want to build the function f plus g of x. And once we've built that function, then we'll be able to substitute the value of 11 into it. The way that you build this function is described in the name. The name is f plus g, and we're going to find that function or build that function by adding the function f to the function g. So f plus g of x means f of x plus g of x. So f of x is the square root of x minus 2. G of x is x squared minus x. So now we have the function f plus g of x. Once we have that function, we're going to evaluate. We want to find f plus g of 11. So we're going to substitute the 11 in for these values of x's in the function. That's square root of 11 minus 2 plus 11 squared minus 11. Square root of 11 minus 2 is square root of 9. 11 squared is 121. Square root of 9 is 3. 121 minus 11 would be 110. And 3 plus 110 would be 113. So we found f plus g of 11 to be 113. So this is one approach for finding f plus g of 11. Let me show you another approach. In this other approach, we start with f plus g of 11. This is the second approach. And what we're going to do is substitute this 11 into each individual function and then do the operation that is mentioned here. That's f of 11 plus g of 11. F of 11 is substituting 11 into the function called f. That's square root of 11 minus 2. G of 11 is substituting 11 into the function called g. It's 11 squared minus 11. And then we want to add those answers together. Square root of 11 minus 2, that's square root of 9. 11 squared is 121. 121 minus 11 would be 110. Square root of 9 is 3. So we found f of 11 to be 3, g of 11 to be 110, and then we add those results together. I'm adding them together because that's the operation indicated here. And we get 113. So that's two different ways that you could have evaluated f plus g of 11. In this example, we have let f of x equal square root of x plus 1 and g of x equal x squared minus x. We want to find and simplify the expression. Our expression is f minus g of 8. I have two different ways that I can work this problem out. I'll show you the first way. In the first way, We can understand what these symbols mean, that we want to evaluate f at 8, evaluate g at 8, and then subtract the 2. So f of 8 would be substituting an 8 into the function named f. That's square root of 8 plus 1, which is square root of 9, which is 3. We want to evaluate g at the value of 8, so we're going to substitute 8 into the function named g. That's 8 squared minus 8, and we need to make sure we subtract that whole expression. We're going to subtract 64 minus 8, and 64 minus 8 is 56. 3 minus 56 is negative 53. That's one way to find this expression, the value of this expression. Another way to find it, if you have f minus g of 8, you would first build the function f minus g of x. That function is f of x minus g of x. That's square root of x plus 1 minus the whole function g of x, x squared minus x. That's square root of x plus 1 minus x squared plus x. And so we've found the function f minus g, and then you would evaluate by substituting 8 into that function. F minus g of 8. That's square root of 8 plus 1 minus 8 squared plus 3. Sorry, not 3, 8. And then we'll simplify. 8 plus 1 is 9. 8 squared is 64. Square root of 9 is 3. Negative 64 plus 8 is negative 56. And 3 minus 56 is negative 53. So we have two ways to find the solution for this problem. On this question, we want to evaluate f over g of 0, given that f of x is equal to square root of x plus 1, and g of x is equal to x squared minus 3. So there are two basic approaches to solving this kind of problem. We want to find f over g of 0. So the first approach to finding f over g of 0 would be to first build the function that it's talking about here. We weren't given the function f over g, so we would first build that function. And in the name of the function, there are instructions on how to build it. F over g of x is the function called f divided by the function called g. And we were given those individual functions of f and g. So we can build this function to be square root of x plus 1 over x squared minus 3. So we have f over g of x being square root of x plus 1 over x squared minus 3. Once we've built that function, then we'll evaluate. So we're going to find f over g of 0, and that means substituting a 0 in for x for this function. So we have square root of 0 plus 1 over 0 squared minus 3. That's square root of 1 over negative 3. Square root of 1 is 1. 1 over negative 3 is negative 1/3. So we've evaluated that function and gotten negative 1/3. So that's one approach. Another approach to solving this problem is to start off with f over g of 0, and if we follow the symbols, follow the meaning of what we see here, this function is f divided by g. So if we do f of 0 divided by g of 0, we're going to be able to get this evaluation. So f of 0 means substitute a 0 in for f. It would be 0 square root of 0 plus 1. And then in the denominator we have g of 0. That means to substitute a 0 into the function called g. That's 0 squared minus 3, and we're going to divide those two. That's why I've put them into the fraction. So we have square root of 1 in the numerator, and in the denominator negative 3. Square root of 1 is 1. 1 over negative 3 is negative 1/3. So you can see either way we've gotten the same answer. On this example, we've been given a picture of two graphs. We have the graph of f written in red here. This is a very interesting graph. It has a feature you may not have seen before. This is called a cusp. It's where it kind of comes to a point and curves out. Looks kind of similar to an absolute value graph, but you can see that the line is curvy instead of straight. In this blue graph, we have a straight line, and that is labeled G. So this curvy one with the cusp is labeled F, and the straight line is labeled G. And on the left here, I have some examples that we're going to work through. We have f plus g of 16, and we're going to simplify this. What this notation wants us to do is to evaluate f at 16, evaluate g at 16, and then add the results together. So I want to identify an x value of 16 on f and an x value of 16 on g. So over here on the right hand side, I can identify on the graph of g a y value of 3, so that's 16,3. And then on the graph of f, that looks like 16,4. So I'm identifying the y coordinate on both of these. So f of 16 would be 4, g of 16 would be 3, and I want to add those results together to get 7. So let's continue on to the next part. We have f minus g of negative 16, and I'm going to evaluate f at negative 16, evaluate g at negative 16, and then subtract the answers. I'm subtracting the answers because of the subtraction in my function notation. So I need to identify an x value of negative 16 and find the y for f, an x value of negative 16 on g and find the y. So over here on the left hand side, I've got this ordered pair, which is on g, and that is the ordered pair negative 16, 1. And this value right here is on the graph of f, and that is negative 16, 4. So f of negative 16 is 4. G of negative 16 is 1, and I want to subtract those values, and that gives 3. In the next example, I want to find g times g of 16. This is the same thing as g of 16 times g of 16. We've already identified g of 16 to be 3. So this is 3 times 3, which is 9. So we notice that we're doing multiplication here because there's multiplication in the function notation. And then finally, we want to do f over g of 1, and that is f of 1 divided by g of 1. So we've got division here. We're doing division of our individual functions. So f of 1 would be right here. This is the ordered pair 1, 1. And g of 1 doesn't look like it gives us a nice number. Okay, so what I've noticed here is I wrote the problem wrong. I wrote this as f over g of 1. It should have been f over g of 16. So let me make that correction. So this is f of 16 divided by g of 16. And we've already found f of 16 to be 4 and g of 16 to be 3. When we divide those, we get 4/3. So f divided by g of 16 is 4/3. We have for the pair of functions defined, find f plus g, f minus g, f times g, and f over g. Give the domain of each. So we're given our f of x. We're given our f of x to be x squared minus 1, and our g of x to be 5x plus 20. So we are going to find f plus g of x. That's going to be f of x plus g of x. That's x squared minus 1 plus 5x plus 20. And we're just going to combine like terms to get x squared plus 5x plus 19. And we've just found our function f plus g. And we're going to find f minus g of x. That's f of x minus g of x. You have to be a little bit more careful with subtraction because we want to make sure that we're subtracting the whole function. So f of x is x squared minus 1. We're going to subtract g of x. I'm putting parentheses around g of x. That's 5x plus 20. We have x squared minus 1 minus 5x minus 20. And we'll combine like terms to get x squared minus 5x, and then negative 1 and the negative 20 combine to be negative 21. So then we're going to multiply, that's f times g, by doing f of x times g of x. F of x is x squared minus 1, and g of x is 5x plus 1 plus 20, and we want to multiply them. So once again, we have to be careful here because we want to multiply all of f by all of g, so we're going to put parentheses so that we multiply all of it and also that it represents multiplication. So when we multiply, we're going to do x squared times 5x, that's 5x cubed. X squared times 20 is going to give me 20x squared. Negative 1 times 5x, it's a minus 5x, and negative 1 times 20 is a minus 20. We don't have any like terms there, and so we won't combine them. So then finally, we're going to find f over g of x. So we're going to put f of x in the numerator and g of x in our denominator. F of x is x squared minus 1, and g of x is 5x plus 20. When we simplify these fractions, we want to make sure that we're reducing it to lowest terms, canceling out any common factors we might have. Our numerator is a difference of squares and can be factored into x plus 1, x minus 1. And our denominator has a greatest common factor of 5. If we factor that out, we get x plus 4. And there are no common factors here, so our rational function is in lowest terms, f over g. We want to come back here and find the domain of each one of these functions. And when we're finding the domain of functions that we add, subtract, multiply, and divide, we have to first consider the original domain. Because if we're using these functions to put together the new functions, we have to have, at the very least, the same restrictions. So both of these functions are polynomial functions, and polynomial functions have a domain of all real numbers, negative infinity to infinity. So the domain of f will be negative infinity to infinity. The domain of g will be negative infinity to infinity. So when we add, subtract, or multiply, because we're having polynomials, they create polynomials. So if you have two polynomials and you add, subtract, or multiply them, you're going to get a polynomial. So all of these new functions have a domain. I'm going to say domain of f plus g is also all real numbers because these are polynomial functions. Domain of f times g is negative infinity to infinity. And domain of f minus g is negative infinity to infinity. Now the division is different. Now when you introduce division, you have now created something that is not a polynomial. This is a rational function. And with rational functions, our denominator cannot be 0. So we're not going to have a domain of all real numbers for the division. We need to take the expression in the denominator, which is our g of x in this example, and set it equal to 0. And we solve, we get 5x equals negative 20, divide by 5, and we get x equals negative 4. That negative 4 is a restricted value because it's going to cause the denominator to equal 0. So our domain here will be everything, all real numbers except for negative 4. And we write that in interval notation. Let me zoom out so I'm not losing part of my question here. Our interval notation will be negative infinity to negative 4, union with negative 4 to infinity. And that's the domain of f over g. Find f plus g, f minus g, f times g, and f over g. Determine the domain for each function. F of x equals square root x, and g of x equals x plus 4. So we want to find these combined functions, f plus g, f minus g, f times g, and f over g, and then also find the domain for each one of those. So to find f plus g of x, we're going to take f of x and add g of x. F of x is square root x, g of x is x plus 4, and there are no like terms here, so this is how we would write our answer, square root of x plus x plus 4. Then with f minus g, we're going to do f of x minus g of x. And with subtraction, we're going to be more careful. We want to make sure that we're subtracting the whole function g of x, so we'll put parentheses around that. That's square root x minus x plus 4. So we put parentheses around all of g of x so we could subtract all of it. We'll distribute that negative, so we get negative x minus 4. And there are no like terms here. So we've got our function f minus g of x to be square root of x minus 4. So then we're going to do multiplication, f times g of x. That's f of x times g of x square root x times x plus 4. You'll notice I put parentheses here as well, and that's because we want to make sure that we're multiplying by all of g of x. If f of x had more than one term, we would also put parentheses around f of x. So we have square root of x times x plus 4. We could use the distributive property and write this as x square root of x plus 4 square root of x. And we have our f times g. And then f over g of x, we're going to put our f of x in the numerator and our g of x in the denominator. F of x is square root x. G of x is x plus 4. And I wouldn't do any simplification to this. There are no common factors. So we have f over g of x being square root of x over x plus 4. We don't want to forget about this second part when we're finding the domain. When we find the domain of combined functions, you have to consider the domain of the individual functions. So we used square root of x to create it. The domain of square root of x is going to be x needs to be greater than or equal to 0, because the square root of negative numbers would give you imaginary. So let me give myself a little bit more space there. So for f of x, which is square root of x, the x needs to be greater than or equal to 0, and if I were to write the domain of f, it would go from 0 to infinity. For g of x is a polynomial, and it doesn't have any restrictions on x, so the domain of g is going to be from negative infinity to infinity. When we use f and g to create that, now we need to bring in the restrictions from those originating functions. And we only have this restriction of x being greater than or equal to 0. So for f plus g, the domain of f plus g, we only need to consider that restriction for 0 to infinity. The same thing happens with subtraction, and the same thing happens with multiplication. However, with division, because we're dividing, we have to make sure that denominator is not equal to 0. So with division, we get this extra restriction that the denominator cannot equal 0. So if we subtract 4, we get x is equal to -4. That's an extra restriction. However, for this example, if you consider the two restrictions we have, x being greater than or equal to 0 and x cannot equal -4, this statement already covers that statement. By x being greater than or equal to 0, we know that x is not equal to -4 because it can only be positives or 0. So our domain for f over g will also be 0 to infinity. But let's consider for just a second here, what if this wasn't an x plus 4? What if it was a -4? If it was x minus 4, we would add 4, and now we have this extra restriction that x cannot equal 4. So what I'm talking about right here is hypothetical. So if our f was still square root of x, but our g was x minus 4. So in this hypothetical scenario, our restrictions are that x is greater than or equal to 0 and x cannot equal 4. So if x needs to be greater than 0 and not equal to 4, we have to exclude 4, but include everything else that's greater than 0. We would get a domain of f over g to be 0 to 4 union with 4 to infinity. So these are all the numbers that are greater than 0 except for 4, greater than or equal to 0 except for 4. Let me zoom out so you can see the whole thing. And remember down here, this is our hypothetical example. On this question, we want to find f composed with g of x for the indicated functions and simplify. So the indicated functions are f of x equal to 8x plus 1 and g of x equal to 4 over x plus 1. So these symbols, f composed with g of x, this symbol here is an operation on functions, and that operation is substituting one of the functions inside of the other function. So what it means is that we're going to take the function that is in front of the composition symbol, that's our outside function, and the function behind the composition symbol, that's our inside function, and we're going to do that substitution. So for this example, we're substituting g of x, which is 4 over x plus 1, into f. And when we substitute it in for f, we put it in place of the variable, because what's inside the parentheses is our placeholder for that. So we're going to put in place of that x, 4 over x plus 1. That's going to give 8 times 4 over x plus 1 plus 1. And when we multiply here, we consider that 8 to be 8 over 1 times the fraction 4 over x plus 1. And we multiply those fractions together, and you multiply numerator times numerator and denominator times denominator. So this gives 32 over x plus 1 plus 1. Now we're going to take it a little bit further, and we're going to simplify this to be in a single fraction. So we have 32 over x plus 1 plus 1, and we treat 1 as 1 over 1. And to get a common denominator, we would multiply by the other denominator, x plus 1 over x plus 1. That gives 32 over x plus 1 plus x plus 1 over x plus 1. Now we have fractions with a common denominator. We can combine the numerators. That's 32 plus x plus 1. And 32 plus 1 is 33. So we have x plus 33 over x plus 1. So we were able to work out that f composed with g of x is equal to x plus 33 over x plus 1. In this question, we're given f of x to equal negative 5 over x plus 1 and g of x equals square root of x plus 21. We want to find f composed with g of negative 5. There are a couple ways we can go about this. One way to go about this is to build or construct the function f composed with g, and then once we've built that function, then substitute the negative 5 into that function. So let's start with that way, and then I'll show you another way after that. So if we want to find f composed with g of x, we need to know what the operation of composition actually means. This operation of composition means to substitute one function inside of another function. And the way that we write it is that the outside function is the one that's written to the left of the composition symbol, and the inside function is the one that's written to the right of the composition symbol. So I'm going to be substituting g of x into f of x. So to do that, I'm going to take this function g of x, and it's going to get substituted into f of x, and it gets substituted in for this x and any x that might be in the equation of f. So that would give us the equation negative 5 over square root of x plus 21 plus 1. So this is the function f composed with g, negative 5 over square root of x plus 21 plus 1. Now that we have built or constructed that function, I'm going to be able to substitute a negative 5 into the function. That would give me negative 5 over the square root of negative 5 plus 21 plus 1. Negative 5 plus 21 is 16. Square root of 16 is 4. 4 plus 1 is 5, and negative 5 over 5 is negative 1. So we were able to calculate f composed with g of negative 5 to be negative 1. But now I'll talk about the other way you might be able to find f composed with g of negative 5. So I'm going to start with f composed with g of negative 5. And once again, I want to keep in mind what this operation of composition means. It means substituting one function inside of another function. So that means that I can write this as f of g of negative 5. G of negative 5 means to substitute negative 5 into the function called g. So into this function, g of x, I'm going to substitute a negative 5. So that's square root of negative 5 plus 21 And negative 5 plus 21 is 16, and the square root of 16 is 4. And now that I've worked out that inside part, worked out the inside, I can now work out f of 4. F of 4 means to substitute a 4 into the function called f. So when we do that, we would have negative 5 over 4 plus 1. Negative 5 over 5 is a negative 1. So we've got the same answer that we worked out in a different way. Thank you for checking out my videos. Have a great day.